Right. What is collusion domain and what is broadcast? This is one of the important uh, variation concepts that we should know. You see, the word domain. The word domain shows control, pollution control. So while traffic move from one device to another device, there are chances of getting collided. Now, how is that collision avoided? Is what collision domain is. How is that collision controlled, avoided? How is that possibility of collision is avoided? Whatever you have learned from that CCNA video, we will talk about that later. Now we are just talking in general, what is collision domain? A collision domain is a network segment where data packets can collide with one another when being sent on a shared medium. And mostly collision happens when there is half duplex Ethernet network. See, this is a common definition for collision domain. This won't fit for all environment. Here they are giving one small example where a collision can occur. Let's say you have a small road, half duplex. In that small road only, both going and coming should happen. Okay, assume like a bridge. There is a bridge. The road is really broad, but in the middle, there is a bridge. That bridge is an olden days bridge, like Britishers, when they were in India, they built that bridge. And still we are maintaining and using only that bridge, assume. I have seen many bridges like that in Tamil Nadu, mostly. Older bridge. It is very narrow, but the roads are really wide. But when the bridge comes, everyone stops, slows down, because it is just a one way space only you have. Either you can go or you can come. That is what called as half duplex. Both going and coming cannot happen at the same time. Either one bus can go from this end of the bridge to that end of the outside the bridge, go to the other side of the bridge, or a bus can come inside to this side, from that side to this side of the bridge. Both cannot happen at the same time. You see, this is one example where collision may occur if both tries to come at the same time. Collision. So there is a controller that makes sure only one bus at a time use the bridge. Either the bus goes to that other direction, or the bus that comes to this direction. That is what collision domain, collision control. See, if it is two-way, like a highway, you will have a divider in the middle of the road. All the bus that goes will use a dedicated road. All the bus that comes will have a dedicated road. Coming bus won't go in this road. Going bus won't go in that road. Especially intercity roads, intercity roads or interstate roads, you see. They are like 4-way, 6-way, 8-way roads. If it is 8-way road, 4 roads are meant for going, 4 roads are meant for coming. So there is no chance of collision. There is no one coming in the opposite. That is how collision domain you see in the highway. So what do we understand from this three-line definition of collision domain? Collusion control. That is what collision domain is. Now, let's go down and read further. Think of it like, imagine multiple people trying to talk at the same time in a room. If two talks at once, their voice collide and neither is understood. Yeah, see, right now I'm talking. While I'm talking, if you also have something in your mind and if you also keep talking, I'm also having something in mind. I'm talking. You're also having some different thing in your mind and you're talking. We both don't understand because my brain is processing something and trying to explain you, and your brain is thinking something and trying to explain me. And our words is only waste. The talk, the conversation is waste there. It is wasted there because neither I receive nor you receive. Both are only giving. No one is ready to receive. That's the problem for collusion. When one is giving, the other should receive. Then collusion is not possible. But when both give at the same time, that's the problem. It is not exactly this picture also. This one was also telling us this is the bridge. Both are trying to give, meaning this bus also want to go, this bus also want to go. But there is only one bus bandwidth in the bridge. Only one bus can go, but both are trying to go and no one can go because there's a collusion, collides. That need to be controlled. Collision need to be controlled. How we put like signal. If this is the bridge, you have a signal here and you have a signal light here. If that turns green, then it means that side can enter, while this is in a red color. That is how we avoid collusion. Collusion domain is the signal. The signal that you keep is a collision controller, collision domain. Now, collision happens when two devices send data at the same time on the same network segment. This is important word. Now we are getting into the technical side of collision domain, network perspective collision domain. Collision happens when two devices send data at the same time on same network. Let's take a switch. Switch is a layer 2 device. So you will have members of the switch in same network. Members of the switch will be in same network. See, they say same network segment. If this is 10.0.0.1 and 10.0.0.2, 10.0.0.3, 10.0.0.4, 10.0.0.5. They are on same network. If all talk at the same time, collusion happens. For example, hub will have, if this is a hub, the hub will have one common backbone. Logical bus topology. It's not physical bus topology. Logically inside this is how you will find. So any traffic that hits the backbone will be sent to everyone. So if all at the same time tries to hit the backbone, definitely there is going to be collusion. There's going to be a collision. More the number of device, more collusion. And there will be total traffic jam here. No one can move. Hub has got only one collusion domain. That's what I just explained. Only one collusion controller. This is the only backbone that is responsible for avoiding collusion. See, if the backbone is wide enough to accommodate 8 PCs traffic, you cannot send a ninth, you cannot connect the ninth PC because the backbone can accommodate only maximum of 8 PC. If all 8 PC talks at the same time, can be managed. Collision can be managed. They adjust and they somehow go. Even though they all talk at the same time, the traffic somehow manages to reach. But if you keep adding more PCs, 9th, 10th, then it cannot take it. The backbone cannot control. Now, hub has got only one collision domain, meaning only one backbone. That is the backbone in which somehow everyone should manage and go. That is why hub don't have more than 8 ports. Whereas bridges and switches, they are layer 2 device. Bridges and switches, they have separate collusion controller on each port. They have separate collusion controller on each port. If I have 24 ports, then I have 24 controllers to control the collusion. Whereas in the hub, there is only one collusion controller. In switches and in bridges, they learn MAC address. Because they learn MAC address, the switch knows who is connected where. So they all can form a dedicated path that avoids collusion. That's how the collusion is controlled. If you have one common path, collusion problem. You cannot have more traffic. But when every traffic can take a dedicated path by knowing where the destination is connected, there won't be collusion. The collusion is controlled. Say, for example, here what they written. If you have 4 computers connected to a hub, all are in one common same collusion controller. That common one collusion controller only have to take responsibility of avoiding collusion. It's like only one teacher to manage 4 babysitter. Not that easy to control babies. 4 baby just joined in the school and only one teacher. Very difficult. First day. But if you have every child one babysitter, then it is easy for the controller to control the child, to pacify, to make the child comfortable, to make the baby stop crying, make the baby laugh. It is possible. Switches are like that. Each computer have got their own collusion domain, meaning they have their own path, so collusion is being controlled. Did you understand collusion domain? All right. Let's move on to the broadcast domain. What is broadcast domain? This is easier than the collision domain. Broadcast domain is that one common backbone which will take any traffic that hits to all the connected devices. It's a broadcast domain. Broadcast controller. When a traffic hits the backbone, this is logical bus. When a traffic hits the backbone, to what all connected devices the packet should go is determined by this backbone. To what all connected device the traffic should go is determined by this backbone. If I have a break in the backbone, cannot erase white color. If I have a break in the backbone, then now I have two broadcast domain. How? The broadcast that goes to this port will be sent here and here. Because there is a break here, it won't go to the other end, other side, other two computer. It won't go to the other two computer. And when a traffic goes and hits the backbone, it only goes here, which means two broadcast domain. In a switch by default, there will be only one broadcast domain. Meaning what? There is one path connecting everyone to take the traffic to all. Okay, the broadcast domain, as I said, to what all connected device the traffic should go is controlled by a controller. That is what broadcast domain. For example, this backbone is a controller. If this backbone is connected to all the device, then any packet hits that backbone will go to everyone. Which means all these 5 devices are in a single broadcast domain. By default, in a switch, this is how you will see. You will see all the connected devices connected to one common backbone. If I have 24 port, all 24 port will be connected to one common backbone. So you have one broadcast domain. A broadcast domain is a network segment in which a broadcast packet can be received by all devices within the domain. As I said, anything that hits this logic, again, this is not a physical backbone, logical backbone. It will be sent to all the device. That's the meaning of it. It's like, someone shouting in a room where everyone can hear. That is broadcast. See, if I shout from here, who all can hear me in this physical realm where I am? I'm in a village. I'm shouting from my room. Can someone in the next street hear me? No. Which means we are not in that same broadcast domain. But if I shout, definitely my house members in other rooms, in first floor, in garden, they all can come and see what happened to me if I shout. Which means they're all in same broadcast domain. So broadcast domain is that distance or the limit within which my traffic will go. You understood? Now let us see this one. A broadcast are used by protocols like ARP and DHCP. Yes, There is a protocol called ARP, Address Resolution Protocol, and there is a protocol called Dynamic Host Configuration Protocol. These two services, these two protocols will do layer 2 broadcast. Using MAC address, broadcast address, it will broadcast. So whoever will receive this traffic, ARP traffic, they're all in same broadcast domain. By default, a switch, by default, a switch will have one broadcast domain. In another word, one VLAN. But if you create a VLAN and put these two interface in another VLAN, then it becomes two broadcast domain in the switch. So when a broadcast is sent, when an ARP request is sent, it will go only to this and this, not to the other two, because the other two is in different broadcast domain. Right? Broadcast controller. So the domain word, if you replace it with the word controller, then you will know the meaning of it. Switches by default do not break the broadcast domain, meaning there will be only one VLAN, one broadcast domain. But you can create more VLANs to break the big broadcast domain into multiple small broadcast domain. See, if you take a router, every port belongs to a network. We saw now, even yesterday I gave you an exercise. G000, we gave 10.0.0.3, and G0/0/1, 20.0.0.3. These two are in two different broadcast domain. See, this is one LAN I told you. This is one broadcast domain. One LAN. That's what here it is called as virtual LAN. You can take it as LAN also. One LAN is one broadcast domain. This is another LAN, so another broadcast domain. You understood? Okay, now if 10 computers are connected to same switch on same VLAN, meaning same LAN, just ignore the VLAN word, we will be covering later. They are all in single broadcast domain because they are in same backbone. This is what one VLAN, this is another VLAN. We'll logically break down the broadcast domain. That is what called as VLAN, which we'll be covering later. If a router separates two group of device, then each group is a broadcast domain that I just explained here. Right. Now summary comparison. Collusion domain, broadcast domain. Scope affects the Ethernet collusions, affects broadcast traffic. What does collusion domain take care of? The collusions. It controls the collusions on the Ethernet wire. What does the broadcast domain takes care of? It controls the broadcast. Who all should get the packet is decided by the broadcast domain. Here, affected. All devices are sharing. All devices are in same what? Wait, I think there's a next. I don't think I will take it to the next. Where is the cursor? And just push the page down, the summary page. All devices sharing the same media. This is about collusion domain. Means all devices sharing same media. Someone should control the collusion. Broadcast domain. All devices sharing in the same VLAN or subnet. Or a LAN, doesn't matter. It can be a LAN also. See, where does the collusion domain plays a major role? To avoid collision, if everyone is sharing one common backbone, there will be a lot of collision. So there is a collision domain needed to control the collision. Here, this is saying who all can talk together. Members of same VLAN can talk together. Members of same subnet can talk. That is what broadcast domain. Okay, the collision domain is divided by switches, bridges, and routers, but not in the hub. Hub never divides collision domain. There is only one collision domain in a hub. Whereas in switch, as I told you, switches and bridges and routers, each port has got a separate collision domain. What about the broadcast domain? Each port of a router is a broadcast domain. Each VLAN is a broadcast domain. Okay, collision domain is not divided in hub and repeater. Whereas broadcast domain can be divided by creating VLANs, which is a later topic. But you should have understood already what is VLAN. We take one big broadcast domain, we break it into small domains, broadcast domains. Okay, why do we need collision domain? To reduce the collision. When you reduce the collision, the efficiency get increased. Why do we need broadcast domain? To reduce broadcast traffic so that you will have increased security. All right. So, are you clear with this topic, collision domain and broadcast domain?